Right, this is 3.2 quadratic equations. Equations, functions, zeros, and models. That's an M-O-D-E-L-S. Any quadratic equation is something that can be written in the form, let me write equation out. It can look like ax squared plus bx plus c equals 0. A cannot equal 0 is basically that because if this was 0 right here, this ax squared term would become 0, and then I would just have bx plus c. And that's not a quadratic equation there. Okay, so this is like the only thing that we cannot have is that just can't be 0 up front. This form right here, where it's written like ax squared plus bx plus c, is also called our standard form of a quadratic equation. Standard form. But then you also have quadratic functions. The only difference between their basic standardness, so a quadratic function, is just that it's written in function notation. So function notation is f of x equals ax squared plus bx plus c. A can still not equal 0, so you have the same thing. And a, b, and c are all real numbers. Real numbers, so a, b, and c are real. I'm just going to write my fancy R for real, which just means no i's for my coefficients. So a, b, and c are considered coefficients. So a, b, and c are coefficients, which just means it's the number in front. So when I talk about, this is really supposed to be one word. It's not supposed to be like two like I have it written. So coefficients are strictly just the number in front of the variables. And actually, never mind, A and B are coefficients, but C is a constant. Okay, so C is a constant, the other two are coefficients. We have a couple different ways that we're going to use to actually solve for 0 on these things. If I'm going to have a couple factors, which I will call, they call it A and B when they show the example, I'm going to call x times y. X times y equals 0. This is going to be an example of the 0, they call it the principle of 0 products. So let me write it out again better. Principle of 0 products. Basically, when you hear that, listen for me saying 0 and products. I usually call it like the 0 product property instead of principle. This just says that if two numbers multiplied together equal 0, the x has to equal 0 or the y has to equal 0. What we're going to use this for is when we factor, we're actually going to figure out what both of them would be to equal 0. They don't always both have to be equal to 0 though. Just one of them has to be. Then you also have the principle of square roots. So it's LE for sure. Principle of square roots. Whoops, that's a Q. Square roots. And what we're going to use for that is if I have x squared equals a number, they use k, I'm just going to use a number symbol, I guess. How do I solve this? What's the inverse operation of squaring the x? Then I have to take the square root of both sides. So then I will have x then equals the square root of the number, but I also have the negative square root of all my numbers, so negative number. Okay, the negative out here, when I'm talking about my two different square roots, I'm talking about the positive and the negative with the negative outside. Let's go through a couple factoring problems. So this is a problem that they give you. I have 2x squared minus x equals 3. Is this in standard form? Is this a standard quadratic equation? No, I have to get my 3 over to the other side. This always has to be equal to 0 in order to be able to factor properly. So 2x squared minus x minus 3. Then what I have to do is I like to do this piece off to the side. I have 2 times negative 3, which is a times c. 2 times negative 3 is negative 6. Then my b goes right here, and that is negative 1. So pay attention to your signs for sure. I'm looking for 2 numbers down here that multiply to 6, or negative 6, and add to negative 1. So what I can just start doing is listing off my things. So I have 1 and 6. Oh, then I have to think about it. Oh, one of them has to be negative to get to negative 6. Does that add to negative 1? No. How about negative 1 and positive 6? No. Doesn't add to 1. So then I have 2 and 3. 2 and 3 and 3 and 2. And then you just have to figure out which one has to be. That doesn't, it's not really. So let's do this one negative and this one negative. And you just have to decide which one is negative. You don't have to write out all your pairs. It's helpful if you cannot find the pair of numbers. Is negative 2 and positive 3 negative 1? No. Is negative 2 and is negative 3 and positive 2? Yes, that adds to negative 1. Okay, then I'm going to take negative x. Negative x is I'm going to replace that with negative 3x and 2x. So I have 2x squared minus 3x plus 2x minus 3 equals 0 still. So this, all I did is I replaced this negative x with these 2 numbers right here. Okay, then I'm going to factor by grouping. So factor by grouping is probably one of the most important things that we're actually going to do. And it really is just, I think a lot of you guys are already good at it, but hopefully we'll really be good at it all by the end. What comes out of 2x squared and 3x? Just x. You can write a 1 if you want to, you don't have to. What's 2x squared divided by x? Okay, all I do is lose a power of x. What's negative 3x divided by x? That's just negative 3. All right, what can I pull out of 2x and minus 3? Oh, I can't pull out anything, so I'm just going to rewrite it, but I'm going to leave a space here. If I can't pull out anything at all, I need to write plus 1 in here. Okay, that's going to be one of the most helpful things to realize that that's going to help us to factor things. Okay, we have to have this plus 1 in here. You'll always have a plus or minus some number. Okay, so what we do is we take these 2 things, but if you really only think about it, like I only have like 2 really big terms. I have this plus sign in the middle. Remember, it's the plus sign that separates our big terms. Okay, I have a 2x minus 3 in both of those terms. But if I pull this 2x minus 3 out of this first term, what am I left with? If I just yank that out, I'm just left with an x. If I pull a 2x minus 3 out of the second term, I'm just left with a plus 1. Okay, I need to have my signs in there, so I have 2x minus 3, and then I have my x plus 1. Still equals 0. Now to actually solve this guy, I use my principle of 0 products is what they call it again. So I'm going to keep forgetting what they call it. Now I'm going to just kind of come over here. So I have 2x minus 3 equals 0. That's my one equation. Then I have x plus 1 equals 0. I like doing them side by side. Definitely don't write them on top of each other because then we're still going to have to solve these things. So I have 2x plus equals positive 3. Then I divide by 2. If I can write, we can. Then I have x equals 3 halves. We can just leave it as 3 halves. This guy, when I solve this, I just subtract 1, and I get x equals negative 1. That's what I would do if I were asked to solve this equation that they gave us up here. So this is what you'll start with, and this is what you'll end with. All right, I'm going to do number 10 in the book. So number 10 says I have 2x squared minus 2 equals 0. I can tell real quick that my a is 2, my b, I don't see a b, so my b is 0, and my c is negative 2. Anytime that you have this, that you don't have a b term because you don't have something x, it's really easy to solve it actually. Okay, oh whoops, let me give this 20. My c is negative 20, and that will make it a better problem. which will make it look ugly, but it'll be easier to see what actually happens. When I have no b term, I actually want to get my x's on one side, my numbers on the other, just like we've solved linear equations forever. Almost forever, I guess. Equals positive 20. Keep solving this. What's the inverse operation of 2 times x squared? Dividing by 2. Then I have x squared equals 10. What's the inverse operation of squaring something? I take the square root of both sides. Okay, and then I come up with two equations. I always will have two equations. I have x equals square root of 10 and x equals negative square root of 10. Okay, then I have to ask myself on all these ones, can I factor 10 down? 5 and 2, nope, I don't have any pairs. This is as simple as your answers get. Okay, the other way that you could write your answer is x equals plus or minus 10, square root 10, sorry. So either these two answers here or this one is what I'd be fine with. Okay, I like seeing them both too, so I won't be mad if you write both of them. And that is how we use our square root principle to solve equations. I kind of want to go back and look at this last one that we did. If I had to look at this on a graph, so hopefully you guys left a little bit of room because I kind of did leave a little bit of room. What this is going to look like on our graph is I'm going to have a solution at 3 halves. 3 halves is really a 1.5. So I'm going to have a point between 1.5 and then I have negative 1. So negative 1, positive 3.5, 1.5, which is 3 halves, sorry. And I know I'm going to either have something that kind of, I know it's going to be U-shaped, so I don't know if it's going to be like this or like this through these dots. Okay, so then I have to go over here and look at this. This is positive in front of my x squared. Positive opens up. So I have something, and I know my solutions look like this. So here, if you were given this graph, you would just look at it and be like x equals negative 1 and 3 halves. Okay, so let me just kind of go to a new page, and if you just looked at my graph. So let me count. I have 1, 2, 3, and let's go 1, 2, 3 there. I'm not really good at spacing. So here, I would just say x equals negative 3, and x equals, I'm going to go with 2.5, so 2.5. So make sure you notice that this one's negative. Okay, so really like that's, you will have to say there's 2 real zeros, and then we have another process called completing the square. Completing the square is really helpful in factoring. So we're actually going to look at a couple of examples that are not necessarily completing the square so that we can actually see what happens when we complete the square. So there's always a couple of really nice things that solve really nicely. Of course, I'm not going to give you those nice ones right away. So if I have x squared plus 6x plus 9 equals 16. So this is a really nice example that I'm giving you guys. What does this factor down into? So when I do my factors, remember I have to do a times c. A times c, that's 1 times 9. That's just 9. My b term is 6. When I'm completing the square, I want these two numbers to be the same, the numbers that add to 6. So what numbers multiply to 9? 3 and 3. Do those also add to 6? Yes, they do. Are they actually positive for that 9? Yes. Okay, that factors into x plus 3 because they're positive, x plus 3. I still have equals 16. I'm not really doing anything with that. When I have any two things next to each other like this, I can rewrite it, and they're the same thing, not any two things. They have to be the same thing. X plus 3 all squared equals 16. I'm going to go through the same process of how do I solve this. Okay, I take the square root of both sides because I have this squared that I have to get rid of. When I take the square root, I have x plus 3 equals the square root of 16. But the square root of 16, if I had to factor it, you should be like 4 and 4. I have a pair of 4s if you didn't know your square roots. If you didn't know your square roots, that's great, but sometimes they won't always work out so nice. And then I have x plus 3 equals negative 4. Okay, I subtract 3 from everywhere because I have two equations for my square root. Remember, I have my positive and my negative square root. That's why I did that. And I get x equals 1 and x equals -7. Okay, gives me really nice answers. This process was not necessarily completing the square, but this was solving with square roots is what this is kind of called. If I had to look at this on the graph, I would have 1, 2, 3, 4, 5, 6, 7, and I would have a dot here, and then a dot at 1, and it goes something like this. Not terribly worried about everything that happened. I just needed to kind of plot those points. So again, if you were just looking at this graph, you would know that it was -7 and 1 from what the graph showed you. All right, everything now, this is going to be an example of completing the square. I have 2x squared minus 1 equals 3x. Basically, what I need to start with is I need to get my x's on one side and my numbers on the other side. So I'm going to add 1 and I'm going to subtract 3x from both sides. But I don't want to write it because I have too much of a mess going on there. So I have 2x squared minus 3x. I need that space actually. That works out really great. Equals +1. I need a space over here too, but I don't really need it yet. In order to complete the square, I can't have this number out front. Okay, so I need just a plain old 1x squared. So how do I get from 2 to 1? I divide by 2. I have to go through and divide every single thing by 2. You don't really need to actually write these spaces yet, but you will on the next line. Okay, this is nice now. I have x squared minus 3/2 x. So that one's not so pretty. Now I need some spaces in there. Equals 1/2. Okay, and this is probably about as gross as these things get. I need spaces on both sides. Now, in order to complete the square, remember, like if we go back and look at this 6 and 9 example with 1x squared and 6x plus 9, it factored really nicely. But I had to know what I have to add to both sides because this doesn't really factor nicely. I need to have something squared. I need to have x plus or minus something squared. And I can't do that right now. So I know, because this is my b, that I have to add to 3/2. Okay, I need to figure out what this number is. This number will get added to both sides because I can add anything to both sides. I can add 100 to both sides. It's not helpful, but I can do whatever I want to as long as I do it to both sides. Okay, so I need these two numbers. If I look back over here, I needed these two numbers to be the same. Okay, so how do I find numbers that are the same that add to 6? In this case, that adds to 3/2. Okay, so I have to take half of that number is what I'm going to have to do. So this really is about as gross as they're going to get, guys. I have 3/2, -3/2 times 1/2. That's how I find half of a fraction. Is just multiply it by 1/2. That will be -3/4. I need two of these numbers now, so I have -3/4 and -3/4. If we want to just make sure that works, I have -3/4 plus -3/4. I already have a common denominator. I would have -6/4, and that reduces down to -3/2. Okay, so that works. That adds to those numbers. Now I still have to figure out what my multiplication number is. This process that we're doing is completing the square, and that's why we're doing it, is so we can complete the square. And I have 3 times 3 is 9. 4 times 4 is 16, and then I had a negative and a negative, which is positive. So I'm going to do plus 9/16 plus 9/16. Oh man, this side is kind of gross, but this side actually is really good. This is what I want on this side. This side, I still need to get a common denominator to actually add these things. So I ask myself, what's my common denominator? What, does 2 go into 16? Yes. So I need to multiply it by 8 to get to 16. Okay, so that new number is going to be 8/16 plus 9/16, and that's going to give me 17/16. I don't even care that it's gross looking, but now I have to figure out what my factor is. Whatever these two numbers are will be what goes in my squared box. That's a 4 right there. Okay, so this is, we kind of have to do, I like to do this my chart off to the side, so they add to -3/2. This is not quite my last step, okay, but we're getting closer. I take the square root of both sides. Then I have my two equations that I write down. I have x minus 3/4 equals the square root of 17/16. And then I have x minus 3/4 equals negative square root of 17/16. Okay? When I take the square root of fractions, I can take the square root of the top and the square root of the bottom separately. On top, it doesn't really help me. I just have the square root of 17. But on bottom, I have 4. Okay, this looks kind of gross, but look how my square root signs were different from each other in this step and this step. You need to make sure you're actually doing that. Let me finish writing 3/4. This one doesn't really help me either, but I can rewrite negative 17 on top and a 4 on the bottom. Okay, so I'm extending that page. Now I need to add 3/4. Add 3/4. Okay, I'm going to do it over here too. And then it's just common to write the numbery part first before the square rooty part. That's really like good math grammar there. Okay, so I have x equals 3/4. I'm adding here, so I still need to write plus the square root of 17/14 or 17/4. And then I have x equals 3/4 minus the square root of 17/14. Fourths, why am I doing that? Okay, that is what my two answers are going to look like. I could also break it down one more step and write just one thing down. And I have 3/4 plus or minus the square root of 17/4. If I were to complete the square on a nice generic ax squared plus bx plus c equation equals 0, I would end up with what we call the quadratic formula. We're not going to go through all those steps today. So I have my quadratic formula. So this isn't a function, this isn't an equation. When I do all of those steps, what I end up getting is x equals negative b plus minus the square root of b squared minus 4ac divided by 2a. So when you be careful, really write this whole thing out. So write that whole fraction line underneath everything. So I can use my quadratic equation to solve different, any type of quadratic equation. So if I had, for example, if I have 3x squared plus 2x minus 7 equals 0. Okay, everything always has to be equal to 0 right here to use this, so it has to look kind of like this standard form of it. So if I didn't have anything, I'd have to subtract it to get it over to the other side. Okay, I'm going to say my a equals 3, my b equals 2, and my c equals negative 7. So really pay attention to your signs. Anything with those negatives are just going to be negatives with them, or with a minus sign. Okay, so I start writing everything out. So I have negative 2. So if this had already been a negative 2, this is going to change the signs. So really be careful on that. I have plus minus the square root of b squared, which is 2 squared, minus 4 times 3 times negative 7. Really be careful right here. If you're doing it in your calculator especially, write in parentheses around this 2 squared. Because if that had been a negative 2 as well, it would definitely mess up a lot of things if you had not put parentheses around your negatives. Okay, 2 times a is 2 times 3. Okay, I don't know which way I'm going to write. I'm just going to keep coming straight down, I guess. So I have negative 2. I need to take care of everything that I have underneath that square root sign. Everything underneath that square root sign, I have 4 right here. So I'm not going to write out tons of steps. Plus, since I have 2 negatives, I have 12 times 7. So that should be 84. So 4 plus 84 is 88, all over 6. Now what I have to do is I have to go off to the side somewhere. I'm going to take it off to the left side. I have to factor down the square root of 88. I know I have 11 and 8. 8 factors down into 4 and 2 and 2 and 2. Sorry, I'm going so crooked right now. So I have one pair of 2's. So the square root of 88 is going to be 2 out front from this pair. And underneath my square roots, I still have 2 and 11, which is 22. So I rewrite negative 2 plus minus 2 square root 22 all over 6. I have to keep simplifying. In order to keep simplifying, I'm going to pull my greatest common factor out of this top, out of my numerator. So I have a 2 out front. What's negative 2 divided by 2? Negative 1. Then I have plus minus. Do not forget to write ones. Then I have 1 square root 22. All divided by 6. Now as soon as I have that out front and I've factored it, then I can simplify. When I simplify, I have a 1 and a 3 down here. When I keep writing this thing, I have negative 1 plus minus the square root, 1 square root of 22. I don't really have to write that 1 in front of the square root of 22, but I have to write that negative 1 all over 3. That's what your answer is going to look like for this guy. If I had to write it as 2 separate answers, I would have negative 1 plus the square root of 22 over 3, negative 1 minus the square root of 22 over 3. Okay, and especially if you guys can actually like factor down that 22, it's really important to make sure that you don't just stop at writing these. You actually need to go through and solve these things. Then we also have some equations that maybe are not quadratic equations. So if I have 4 x to the 4th minus 5x squared plus 4 equals 0. What I need to do is what we're going to call substitution. I'm going to use the letter U, and we usually call that U substitution. Although don't just like go Google U substitution because it's actually like a calculus thing. Okay, I'm going to say that U is equal to x squared. Okay, so I need to break down this x to the 4th into 2x squareds. Okay, remember my properties of exponents. So this is a U, and this is a U. If I have 2 u's times each other, that's u squared. Minus 5u plus 4 equals 0. It's very important to make this equation over here, so you have to write this thing, and then you'll like kind of go from this step to this step. Okay, if you had any number out front of your x to the 4th, you would just keep on with that number. Okay, and then I would have, I can use my quadratic formula unless you can factor nicely. You can solve these guys however you want to. I can see right now that it factors. So if I were to factor, I'm looking for something that multiplies to 4 and adds to negative 5. I could go in and I could list all my factors. So I could have 2 and 2. I could have, oh, but that doesn't add to negative 5. I can have negative 1 and negative 4. So you just need to recognize these factors, and that adds to negative 5. Okay? Anytime that I have a 1 out here for my plain old, for my a term, this is just going to factor down into x minus 1. X minus 4 equals 0. And these numbers just came from right here, so x minus 1. And you just keep whatever sign they have. So if they were positive, it would be pluses in here. Okay, then I have to solve, I'm sorry, I didn't mean to write x's. These are u's. So you have to actually remember what you're factoring. Then I have u minus 1 equals 0 to use my 0 product property, which is not what your book calls it, I'm sorry. And I have u equals 0. So I need to keep solving these guys. So I add 1 to both sides, add 1, and I get u equals 1. Add 4 to both sides, and I get u equals 4. That's a u. Okay, then I have to come up here. What did I write for my equation? I'm going to use that and put it back. I'm going to put x squared back for my u's and over here. So then I have x squared equals 1. X squared equals 4. How do I go through solving these? I need to take the square roots. What's the square root of 1? Don't forget that you have 2 square roots of 1. I have x equals 1 and x equals negative 1. Square root of 4 over here, I have x equals 2 and x equals negative 2. Okay, you should have 4 answers unless they possibly repeat. They can, so you could get the same answer for like both sides of the equation. But remember, I'm always going to have a positive and a negative, a positive and a negative. Okay. Also try to check with, I have 1, 2, 3, 4 answers. I have 4 for my original degree of this equation. So 4 was my original power out there out front. Okay, so I have 4 answers here for these guys that have those. You also should probably go in and check your answers, like if you have any of the weird square root ones. So you would have to do like up here, if I have x to the fourth, I have to remember what I have at x to the fourth minus 5x squared plus 4. So if I had to solve these guys, so I'll use -2 because it's about the grossest looking one, but I'll just do 1. So I'll have -2 to the fourth minus 5, -2 squared plus 4. And remember that it was equal to 0. I forgot to write that down. Okay, so I have -2 to the fourth. 2 times 2 times 2 times 2 is 16, and I had 4 of them, so it was positive 16. Then I have 2 squared, which is 4. 4 times 5 is 20. That's minus 20, because I have this 1 here and 2 negative signs here. So that's negative. Plus 4 equals 0. We're checking to see if it equals 0. 16 minus 20, that's -4 plus 4. That is equal to 0. So that's how you would check your answers there. Also, I need to talk about in here when I talk about my quadratic formula. So I'm just going to kind of copy this to another page. Okay, what we need to talk about is what's underneath this square root here. This guy has a name. It's called our discriminant. And our discriminant is equal to b squared minus 4ac. It is not the square root. Do not put the square root on top of this. It is just what's underneath there. So I could find the discriminant of anything that I had. And this is where I end up with different types of answers. If my discriminant is positive, I'm going to have 2 real answers. 2 real solutions is how we say it. What that looks like if I came over, I don't remember having any really good example. Let me find one. All right, we didn't actually do one, so I'll just keep going and tell you guys, and we'll go over it in class some more tomorrow. If I have negatives, I have 2 complex solutions. And what's between positive and negative? If it's 0, that's not how you spell 0. So 0 has 1 real solution. And we'll kind of talk about those in class, but make sure you guys have these written down nicely and what your discriminant is. Yep, and we'll just get those talked about in class. Okay, I want you to do 3 through 99 by 3s. And then I also want you to do some of the synthesis stuff, oh, not the synthesis, some of the skill maintenance stuff, which is 115 through 120. And by doing these skill maintenance things, that will keep up on other things that we've learned in the past. And how about you want a page number? It starts on like page 253.